This is GATE 2013 EE question number 30. Three capacitors C1, C2, C3 whose values are 10 microfarad, 5 microfarad and 2 microfarad have breakdown voltages 10, 5, 2. For the interconnection shown, maximum voltage that can be safely applied across the combination. You have to find that, and also you have to find the equivalent capacitance seen across these two nodes. So first we need to see some useful data in order to solve some question regarding of this type. So if you have a capacitor of capacitance C and you have a voltage V that is applied across the capacitor, then the charge stored Q will be like this, same, equal and opposite, plus Q and minus Q, so that mod Q equal to CV, where C is the capacitance, V is the voltage applied across it. So first you need to know this, and then you need to know if capacitors are connected in series like this, C1, C2. This is series connection, and for example capacitors are connected like this. This is parallel connection because the voltage across them are same. So the equivalent capacitance C series across these two nodes, let's say AB, series equivalent for C series AB will be equal to C1 C2 divided by C1 plus C2, and this will be C parallel across this node C and D. So parallel equivalent C parallel across these two nodes, as you see, is C1 plus C2. Also you see, if you have some capacitance like this is C1, this is C2, then as per Gauss law, the charge stored, there is a magnitude of charge induced in this capacitor and this capacitor will be same, right? Because we know these are metal plates. Okay, these are metal plates. Since the metal plates cannot contain an electric field, hence if you draw some surface like this, the electric field is zero here. So since the electric field is zero, flux sheet is zero, and so the net charge enclosed within this surface should be zero. So that's why the charges are induced in equal and opposite manner and should be same for this and this. So charge in series connection, that is series connected capacitors, are same in magnitude. Now you need to see, the question is given like this, the configuration is like this, two capacitors are there like this and one capacitor is there like this, and the capacitances have value C1, C2, C3, 10, 5 and 2. So 10, 5, 2, this is C1, this is C2 and this is C3, and these are the capacitances of these three capacitors, and the breakdown voltages as mentioned for C1, C2, C3 are 10, 5 and 2, same. So 10, I'm writing it like this is 5 and this is 2. So now you see, first let's calculate the equivalent capacitance. 10 plus 10, C2, C3 is 10 by 7, this is 80 by 7, which is 11.4, this is microfarad, all these are in microfarad. Okay, now see that they are asking us what should be the breakdown voltage. Now see the options, what are they telling. The breakdown voltages 2.8 or 7, you have to decide within the two. Now the voltage across C2 into the capacitance of C2 equal to the C3 into V3, that is the voltage across this one, VC3, this is VC2, and the total voltage across them is Vc1. This is Vc1. This is equal because the charge for series connection, I told you magnitude of charge induced for series connected capacitors are same. So we can write this C2V2 equal to C3V3. Now you see V is the applied voltage, for example, across these two nodes A and B. So if VAB equal to V, for example, I apply this voltage. So I should apply this voltage V such that it should be safe for all Vc1, Vc2, Vc3. So V should be such that it is less than Vc1 breakdown voltage, Vc2 breakdown voltage, and Vc3 breakdown voltage. So that then only we can say it is a safe voltage to apply in this configuration. So in order to find that, first let's calculate the voltage across C2 for a voltage of V applied between A and B nodes. So what is, we see that Vc2 equal to C3 by C2 into Vc3, and also V equal to Vc2 plus Vc3, because we are applying a voltage V here. This is V, so Vc2 plus Vc3 must be V. So now we see Vc2, there is voltage across C2 is C3 by C2 Vc2, and Vc3, and Vc3 plus Vc2 is the breakdown voltage limit. Maximum you can go up to that, and it should be equal to the voltage applied. So now if this is 7, so Vc3 plus Vc2 is 7, then what will happen? C3 by C2 we know, C3 by C2 is 2 by 5, so Vc2 equal to 2 by 5 Vc3, just replacing Vc2 value, 2 by 5 plus 1 Vc3 equal to 7, so Vc3 equal to 5 and Vc2 equal to 2. Now Vc3 breakdown is 2, Vc2 breakdown is 5. So Vc3 breakdown is 2, so Vc3 greater than Vc3 breakdown, so we cannot apply 7 volts. Now if 2.8 volt equal to V, that is V applied across AB is 2.8 volt, then in that case Vc3 plus Vc2 is 2.8 and Vc2 equal to 2 by 5 Vc3, and Vc2 value we should replace with 2 by 5, and it will come out to be 7 by 5 Vc3 equal to 2.8, so 0.4. Vc3 equal to 2 volt and Vc2 equal to 0.8 volt. In this case the breakdown voltage of Vc3, it is C3, is 2 and C2 is 5. So breakdown voltage of C3 is reached and breakdown voltage of C2 is not reached, and also the breakdown voltage of C1 is much greater than that coming across C1. It is 10, but we have only 2.8 applied across it, so it is a safe thing to apply. So this will be working, 2.8 volt is fine. So 11.4 microfarad combination C into V is 2.8 is Q, right? So Q equal to, in microcoulomb we need to answer this, so 11.4 into 2.8 is 31.92 microcoulomb. So this is the charge across the effective capacitance, so 31.92 or 32, we can say 32 microcoulomb is the Q equivalent capacitance. So option C is the correct option. Thank you.